Hello, welcome to another lesson in Algebra 1. Today we're covering section 2.2 and 2.3. Get a little bit ahead here. So we're adding and subtracting real numbers, which I think can be combined into one section. Okay. All right, so warm up, tell whether the conditional statement is true or false. If it is false, give a counterexample. So remember, if you haven't tried these, please pause the video and do them yourself. These are some trickier ones, and I think it's new stuff for most of you, so you really need to try them before you just copy answers. All right, so number one, if a number is negative, then its opposite is positive. So if it's negative, its opposite is positive. Can we think of any negative number whose opposite is not positive? I cannot. So I believe this is a true statement. So for instance, like -5, its opposite is +5, and that's going to be a positive number. Okay, so I think everything I can think of that's negative, its opposite is automatically going to be positive. All right, number two, if a number is even, then its opposite is a whole number. So if a number is even, then its opposite is a whole number. All right, so an even number is anything that's divisible by 2 and has no remainder. Okay, so for instance, -4 is an even number, and its opposite would be +4. That's a whole number, so that's okay. All right, but if I start it with +4, that's an even number. Its opposite would be -4, which is not a whole number. So here is going to be false. And our counter example would be +4. +4 is even, but its opposite is negative, so it's not a whole number. Whole numbers start with 0 and count forward. So no negatives. All right, rules for addition. So we add two numbers with the same sign, then you add their absolute values, and the sum has the same sign as the numbers added. Okay? So for instance, the absolute value of 4 is 4, the absolute value of 10 is 10, so it's going to be 14. Both of them had positive for their sign, so our sign for the answer is also positive. Okay? So for the next one, the absolute value of -1 is 1, the absolute value of -3 is 3. You add them together for 4. And then you keep the sign, so since both were negative, we make our answer be -4. Okay? All right, two numbers with different signs. Okay, so subtract the lesser absolute value from the greater absolute value. So the absolute value of 8 is 8, and the absolute value of -5 is 5. So we subtract the lesser from the greater, which will give us 3. That's why I did the 8 part first. And then keep the same sign as the number with the greater absolute value. So 8 has a greater absolute value, and 8 was positive. So we keep a positive sign on the 3. So this will be +3. We don't write the positive, though. All right, so for the second one, the absolute value of -20 is +20, and the absolute value of 10 is 10. We're supposed to subtract the two. This bigger minus the smaller. That gives us 10. And then keep the sign of the one that has the bigger. So 20 had the bigger, and that was currently negative, so we make our answer be negative. Now, I'm sure that you learn many different ways. So these are the technical math ways you see in any math book, but your teacher probably taught you whole bunches of different ways to do this. Any of those that you did in the past is fine, but also remember you had a calculator in your hand, and there is never a reason to make a mistake on integers, okay, adding positive and negative numbers. Okay. All right, so find the sum for each. -6 plus -3 makes -9. Okay, they're the same sign, so I just add and keep the sign. On number 2, 19.3 plus -12.2. So I'm going to do 19.3 minus 12.2, which is 7.1. Those are the absolute values subtracted from each other. And then the bigger one was positive, so we keep positive. Okay. 1 3/4 plus -3. This is a great place to use a calculator. Or you can make it a decimal if you like decimals better. So I'm just going to use a calculator. 1.75 plus -3. This gives me -1.25. Okay, a decimal answer is fine here. -5.3 plus -4.9. -10.2. So this is supposed to be review, so I'm not trying to reteach you how to add and subtract positive numbers. But what we're going to do is basically learn how to use our calculator in class and at home to make sure we don't make mistakes on what we learned in the past. All right, so why do 2 plus 4 and 4 plus 2 have the same value when simplified? And the answer to this is adding in a different order does not change the result. Okay, so you can add in any order you want. Different order does not change the result. Okay, flip it over to the next page. And these lead us to our adding properties. So first property is the commutative property. You'll hear a lot of teachers say commutative because it goes well with this property, what it looks like and what it means, but it's really pronounced commutative. So the commutative property says the order in which you add two numbers does not change. That's just what we were talking about on the last page. It doesn't matter in what order you add, you still get the same answer. So in algebra, that means using variables. We could write it like this. A plus B is the same as B plus A. So A and B could be any real numbers we feel like. We plug them in, and it's the same as if I added them in the opposite order. Okay. Then we have an example with some real numbers. In this case, A is 5 and B is 4. So 5 plus 4 is 9, but 4 plus 5 is also 9. Okay. The way that I remember this is, and why they call it the commutative property, is you can think of this as like, this is the drive from work to home is equal to the drive from home to work. Okay, it doesn't matter which direction we go. All right, associative property. The way you group three numbers in a sum does not change the sum. So we can group them. Okay, so here I group the first two together. Or remember, order of operations would say to do the parentheses part first. Okay, and here I group the second two together. It doesn't matter which ones I group first. When I'm done, I'm going to get the same answer. It's still going to be, for this example, 11 on both sides. Here I add the 9 plus 2 on this side, and on that side I say 5 plus 7, but either way, or 5 plus 6, but either way we get 11. All right, so the way I remember the associative property, okay, is I think about these parts as people. So A and B right now are associating together, and they're rude, mean, bully people, and they don't allow C in their group. But B no longer wants to associate with A because B hurt A's feelings. Maybe he stole his boyfriend or girlfriend or whatever. And now B and C are going to associate together, and they're going to leave A out of the group. Okay? I know none of you do this. You stick together and nice to everybody. But unfortunately, numbers are not nice to everybody. So associative property, because who do they want to associate with first? And B can't seem to decide. All right? All right, identity property. The sum of a number and 0 is the same as that number. So for instance, if I take any number A, add on 0, I still get A back. And here's an example with 5 being A's value. 5 plus 0 is still 5. Okay, so the identity property, adding 0 does not change the identity of that number. So 5 is still going to be 5. We didn't disguise him or change his identity by adding 0 to him. All right? Inverse property, sometimes confused with the identity property on tests and quizzes, is when you add a number to its opposite. So if I take 5 and add them to his opposite, negative 5, I always get 0. If I add a number to its opposite, we always end up with 0. So some people think the 0, oh, I automatically put identity. No, when you add a number to 0, it's identity. When you add a number in its opposite and you get 0, the result, then it's inverse. Okay. Inverse is kind of like another word for opposite. So these are a number plus its inverse, its opposite. Okay. The identity property states that the sum of a number A and 0 is A. The number 0 is called the additive identity. So you can always add 0 onto something and it doesn't change. Okay. The inverse property states that the sum of a number and its opposite is 0. So the opposite of A is called the additive inverse. So a number, 5, plus its additive inverse always makes the additive identity. Okay? Or you can say a number plus the additive identity always makes that same number again. Okay? So we need to know the names for these. Additive identity, and additive inverse also. All right, so this is the part that gives a lot of people trouble on the quizzes and tests, because this is something you can't just pick up your calculator and type in. So it says, identify which property of addition that is demonstrated. Okay, so our first one is associative. It's not because it has parentheses, it's because the grouping symbol changed the order in which I did things. So notice the x, 9, and 2 are in the exact same order. I did is change the grouping symbol so that instead of adding the x and 9 first, now I add the 9 and 2 first. And this allows me to collect the like terms when I do it on the right side. So this is the associative property. And you guys are welcome to abbreviate these. Just be careful with this one when you abbreviate it. Okay? Number 7. We're adding a number plus its inverse, and we end up with 0. So a number plus its additive inverse. And we ended up with the additive identity. Okay, so this guy is the inverse property for addition. And you can just write the first word, associative, inverse, etc. Okay. All right, so negative y plus 0.7 equals 0.7 plus negative y. I changed the order in which I add it, so this is going to be the commutative. Okay. 4 plus parentheses 8 plus x, and then 4 plus parentheses x plus 8. A lot of people get fooled into thinking that this is associative property because it has parentheses, but you have to look careful. It changed the order in which we added the stuff in the parentheses. It did not move the parentheses without changing the order of the numbers, the terms. Instead, it left the parentheses where they were and changed the terms. So this is actually the commutative again. Change the order in which I added up the x and the 8. All right, number 10, 3 plus the additive identity equals 0. So 3 plus 0 is 3. Okay, so I get the same number when I add back 0. So this is the identity property. And then our last one looks like parentheses moved around, but technically this and this changed positions. So the thing I added on the left was 3, changed with the position of the 6 plus 5 on the other side. When things change positions, other than, like the terms, the numbers themselves move around, it's almost always going to be commutative. Okay. All right, last page here, rules for subtraction. So to subtract b from a, instead we add the opposite of b to a. So I know if you were at one of the Stuttgart schools last year, your teacher probably told you this. Leave, change, change, and you're welcome to continue to do that. It means the same thing. Or maybe keep, change, change, or something like that. Add the opposite is what you'll see in most math books, though. So instead of saying a subtract b, we say a plus the opposite of b, which was negative b. Or 5 subtract 10 turns into 5 plus the opposite of 10, which is negative 10. And we can add them up. Okay? So here's 2 examples of add the opposite. One when I have subtract a negative, and one when I have subtract a positive. Okay? So number 12, you don't have to rewrite this, but I'm going to go ahead and do the add the opposite part. 5 plus negative 11 is negative 6. Number 13, 11.2 minus negative 5.5 turns into 11.2 plus 5.5, which is 16.7, I think. Number 14, 1/3 minus 1/2. This is kind of 1/3 plus negative 1/2. I'm going to do this old school this time, so let's get common denominators, which you will have to be able to show work for on the test, and then we'll add those up and get negative 1/6. So I don't require you to show work on this if I just said, hey, what's the answer? But what I do for these kind of problems is I do this. Let me draw it in another pen so you can see it. I would say something like this. 1/3 minus 1/2 equals, something over 6, fill in the box, minus something over 6, fill in the box, and then equals something over 6, fill in this box, and then equals to our final answer. So you have to know how to do common denominators for fractions. It's a skill that you should know how to do. Okay. Number 15, I got this mixed number. I'm going to go ahead and turn it into a decimal. It's a good trick. And then I will say add the opposite. And I'll add up the decimal parts, and I'm going to get 0.75, and I'll add up the whole number parts and get 5, so negative 5.75. I'm adding the absolute values of those and keeping the negative. Okay. All right. The temperature one morning was 14 degrees, and by midday the temperature was negative 3 degrees. What was the change in temperature? To find the change in something, we always do the new temperature or the new something minus the old something. That's a change. So the new temperature in our case is negative 3 minus the old temperature of 14. So our temperature was a negative 17 degrees Celsius drop. Okay, so it went down negative 17 degrees. Okay, all right, or went down 17 degrees actually. All right, check for understanding. So there are 6 questions here. I do have the answers down here, so you should try to ignore them for a minute. Do it yourself, see if you can figure out what they are, and then come back and check your answers. All right, I'll see you in class next time. We'll practice this stuff and then take a quiz.